Hello friends, myself Keyur Nagecha. I am coming from VP Engineering College. Today we will be learning concept of stress, concept of strain, types of stresses, relation between stress and strain, stress strain curve for elastic material, stress and strain in uniform bars, and we will see some numericals. Okay, let's start with the concept. What happens when you apply some force on the object? You can take any object. Let's take an object like this. It's just a rectangular object. We can do various things on it, like we can apply various forces. The one force which we can apply is like this. This particular force is known as pull, or you can also call it as a tension. Another thing you can do is you can apply compression, like you can push it on the both side. This particular type of force is known as compressive force or push. Another thing which you can do is this. That is, previous two forces were normal forces. These are known as tangential forces. This particular type of force is known as tear or shear force. So these are the things which you can do. Apart from this, we can twist the object, and we can twist the object. You can do, rather you can bend the object also. Now, whenever we apply these forces, these particular forces are known as external force. And what happens on a body? Body tends to undergo some deformation. Here the word tends to is important, because it may happen that body may not go under deformation. Like suppose you are pushing the wall. Definitely wall, unless and until you are Superman or superhuman, you will have a dent, but otherwise it will not deform. So those particular materials are known as solid materials. The subject which we are covering is of deformable bodies. So body tends to undergo some deformation. It may deform, it may not deform. Now, due to cohesion between the molecules of the material, body resists the deformation. The resistance by which material of the body opposes the deformation is known as strength of materials. The concept of strength of material is very important for designing purpose. Before we use any material, we need to see the strength of particular material. It may happen that suppose we design one particular object, or let's say simple stool. If it is designed for human, then it must be designed to carry certain load. If it is, that is, before execution, we must know the strength of material, and that is the importance of the subject. We can say that within a certain limit, which is known as elastic limit, the resistance offered by the material is proportional to the deformation brought out by the external force or load. So here elastic limit is important. This you have learned in school days, rather, that is known as Hooke's law. So within elastic limit, the resistance offered by the material, that is, you can say we consider ourselves also whenever we apply, or rather some teacher force you, then you will definitely have some resistance, and that is proportional to the external force or the load. It is directly proportional, we can say. So within elastic stage, the resisting force equals to the applied load, and that is important for the equilibrium. That is, whatever force we apply, the same force we will get as resistance. So if we apply the force which is as a push, then the resistance will be in form of pull or tension. That is, if we apply compressive force, then resistance will be in form of tension. This particular resisting force per unit area is called stress. Now, what is stress? The force of resistance per unit area offered by a body against deformation is known as stress. This is the definition of stress, which gives us idea that it is some kind of resistance. Mathematically, we can write down stress as sigma. Sigma is the notation for the stress. It is equal to P by A, where P is sigma is stress, P is external force or load applied on the object, A is cross-sectional area upon which the force is applied. So this is the mathematical equation to find out the stress. So stress depends upon two values rather. It depends upon the applied load as well as the area on which it is applied. The external force acting on the body is called the load or force. The unit which we take is either Newton or kilonewton. The cross-sectional area is the area of the material on which the load is applied. The unit of the area usually we take as mm square. So if sigma is equal to P by A, the unit of stress is Newton per mm square or kilonewton per mm square, depending upon the magnitude of force we are applying. To solve the examples, we need to understand some important conversions. These conversions helps us to solve the problems because the units are important to get the correct answer. We know the value of Pascal. This you have learned in your school days, that is in 12th or 11th. 1 Pascal is equal to 1 Newton per meter square. So 1 Newton per mm square, if we make the conversion, then it becomes 10 raised to 6 Newton per meter square. 10 raised to 6, you know that it can be written as mega also. So 1 Newton per mm square, we can write it down like this also. 10 raised to 6 Newton per meter square is 1 mega Newton per meter square, and 1 Newton per meter square is nothing but Pascal. So it is equal to 1 megapascal. So we can have the conversion like, using this we can use the conversion 1 Newton per mm square is 1 megapascal. So usually whenever we give the value of the strength of material, we can write down as megapascal or Newton per mm square. Megapascal is the usual notations which we may find at many places. This is the normal unit which we use to indicate the strength of material. The meaning of 1 megapascal strength is that one particular material upon which we are applying various forces can resist or can have the strength of 1 Newton per mm square. That is, if you take the cross section area of the material, so per mm square it can resist 1 Newton force. Let's see various types of stresses, because depending upon the type of force, the stresses will be different. We can divide or we can classify the stress as direct stress or simple stress. As you know, the topic of today is simple stress and strain. So if it is simple, then there must be something which is complicated. So direct stress or simple stress. The direct stresses are tensile stress, compressive stress or compression, and shear stress. Indirect stresses. If direct stresses are there, then there are definitely some stresses will be there which is indirect. So indirect stresses are, we can say they are bending, that is you can bend the material, and torsion, that is known as twisting. Apart from that, what we may have is the compound stresses. That is the any combination of direct and indirect stresses. That is, we can push the object or material, that is pull, and we can bend it at the same time. So combination of more than one stress, that is it may be direct or indirect, is known as compound stress. Right now our object or rather our main focus is on direct stresses. So we will be dealing with direct stresses only. So types of direct stresses. Let's start with the tensile stress. Here one cylindrical bar is there on which we are applying the force. So if we apply force like this, which is known as pull, and because of that what will happen is stresses will be developed, and these stresses are known as tensile stress. Here important thing is you can follow the marker. Here this particular force, that is external force, is try to pull the object, whereas the material, what material will try to do? It will try to resist the deformation. So you can also consider it as a reaction also. It will work on this side, that is the internal stresses. If you consider that, it will be in form of compression, that is the resistance. So this is what will happen. If this is the load, we can take the value as P. To find out the stress, definitely we will need the cross section area. So it is a circular bar, so its cross sectional area will be pi by 4 d square or pi r square, upon which the force is applied. This is what will happen when we apply the direct stress in form of tension. The material will increase in length if it gets deformed. If the length increases, then definitely its cross sectional area will also decrease, because the quantity of material or mass of the material is not changed. To find out the tensile stress, the equation which we will be using is sigma, that is stress, is equal to P by A Newton per mm square or kilonewton per mm square, depending upon the magnitude of external force applied. Compressive stress. Now the same material we take, it's the same cylindrical bar, but instead of pulling it, let's apply the push. So if we push the material, then this is the same thing, it is having the same cross section area, the same magnitude of force is applied, but instead of pulling it, now we are pushing it. So obviously the material will decrease in length, that is length will decrease, and its cross sectional dimension at the center or wherever it is weaker will increase. This happens, that is this deformation occurs only in elastic materials. If we take the brittle material like chalk stick, then if you apply the force, compressive force, then it will not decrease in the length, but rather it will simply break off. The same equation which we will be using to find out the compressive stress, that is sigma is equal to P by A Newton per mm square. The next type of stress is shear stress. Now here tensile and compressive stresses, they act perpendicular to the surface of the material, whereas shear stress acts tangential to the surface of the material. There is a bit difference between this type of stress. Now here, to understand the shear stress, I have taken the example of the bolted connection. Here is the figure of the bolted connection. Here, just to view it, here this plate is there which is covered by this bar, or you can say its connection, and it is bolted. The B is bolt, and here we are applying the force on two components, that is one plate A and another is plate C, and we are applying the tension. Now what will happen, and which material or which component is actually facing the resistance, or is rather giving the resistance? So here it is a common sense that whenever we apply force like this, the force will act actually on the bolt, and bolt will give the resistance. So if we take the side view of the connection, this is what we are having. The same thing, here we are applying the pull. This is the bolt which connects the plates. So here the connection is like this. We can take this as M, P and Q. This connection is tightened by the nut over here. Now we are applying the force in this direction. Now if we consider the forces on bolt, so this is what will happen. that the force on bolt will be like this. This particular plate, that is 1 and 3, will try to push this particular portion of the bolt on this side, whereas the central plate here, this was the upper plate and lower plate, will try to push the bolt on this side. So major stress or major deformation, or you can say major resistance, will be offered over here, that is Mn and Pq. So this is what will happen. As you can see, this is the cross section area, that this is the again larger view of it. So here this particular force, that is V, if we consider, then it is acting in a tensile manner. It is not directly acting. And again, if we further take a look at the cross section, this is the circular cross section of the nut, or we can say bolt. So if we take the cross section of the bolt, definitely it will be circular, and the stress developed will be tangential, and that is known as shear stress. So shear stress is tangential stress acting on a body. Another example, if we take, then the same kind of force we apply, and this is what will happen to the bolt. As you can see, in case of tension, we are applying the pull in this direction. In case of compression, we are applying force on this side. Here, to find out the shear stress, the force is applied like this from over here and from here. So this particular cross section, that is the circular cross section, will be in shear. If the bolt fails, that is if it breaks into two pieces, the type of failure is known as shear failure. So shear stress, if you want to find out, then usually shear stress is denoted as tau or tau, which is equal to P, that is load, divided by A, that is area under shear. The unit of shear stress is Newton per mm square. Now let's talk about the indirect stresses. These indirect stresses are not actually the part of simple stress and strain. You will be learning about bending stress and shear stress later on. There are two different topics on it, but